How's it going, everyone? Julian Gonzalez here. Today, we're going to explore now the functional light JavaScript. This is a course and a book taught by Kyle Simpson. So the goal of this series of videos and in this course is to learn the fundamental, conceptual, and applicable tools from the functional programmers and see how we can now apply that into our own code bases, specifically on UI development, so we can now get the benefits of that our code is provable, aka that this is part of the value proposition of this. We have now rest assured that section of code will work as expected, while we can focus is on things that we don't have high degree of confidence. And this is now why functional programming has been so valuable in terms of using these mathematical concepts. Pretty much like when you go into a restaurant and you have to pay the bills, right? You don't need the mathematical proof of 2 plus 2 is equals 4, or that the arithmetic mathematical proof of the addition, subtractions, and division, multiplication, or where is the mathematical proof of the numbers? How the numbers kicks in. It is quite interesting to know, all right? However, for your daily life, we just want to look at this tool and use it, right? So, this is pretty much the approach of how now Kyle Simpson, when he created this book, it was with that goal in mind. And I really appreciate that, because most of the time we come from this JavaScript background or in an imperative programming coding style like C, C++. And when you tell the machine how to do the stuff, not what to do. And now with the AI, this has become more and more and more relevant, I will say. Why is that? Because even though that you can tell the machine or your UI model, your chat model, is that all those the step that you want to go with, instead you just is describe what you want to do, and you refine that process. Okay, so the idea here is that in this course or in today's video is to look at now that particular technique called point free that would allow us is to see the benefits and understand how do we get here, so we can talk about the point free and finally is run into some exercise. All right. Let's get into this. So we're going to look at this quick recap of introduction, function, purity, arguments, adapters, and point free. Okay. Again, today we're gonna look at an example of that. And the introduction is just 4 words, the way of how you can present over the sales pitch. All right, is that why we're looking at this? What is the approach that we are going to take? From Kyle Simpson, which is taking what we already know from the imperative approach, and then slowly and progressively going to move the needle towards the functional approach by using all of this set of principles and tools, where the value proposition of that is that our code is provable. So by so if you can think of a section of your code base that you know that will work as expected, so you have now high level of confidence that that's gonna do what it's supposed to, so you can focus your attention on stuff that you don't have that kind of confidence. Now, because learning functional programming is something that can be quite challenging, especially as anything that is new, it will take you a learning curve. And this is something that, for example, he described that what will be that, or what might look like that journey in terms of an axis, where on the g-axis, on the on the g-axis you have is readability, and on the x-axis you have time, and you go from one to another, the imperative and then to declarative, and well, once you reach to this point of the pit of despair, so the idea is to keep pushing, because perhaps there's a couple of stuff that doesn't make sense a lot as you go and progress through all the stuff, but over the weeks or month is something that you will say, oh, and I get it, right? And then you're going to put your special sunglasses anytime you need to look at a code base with this functional approach. So let's go to actually describe is these particularly models, right? It's going to talk with functions, and then with argument adapters, and point three, and finally is going to type something, right? So the functions, at the end of the day, unlike procedures, you must receive inputs and return something. So procedures, at the end of the day, unlike functions, they don't necessarily return something. In JavaScript, at the end of the day, you always are returning something, especially if you have a function, it's going to return something. No matter if you don't declare that, it's going to return is undefined, if you don't define anything. But to understand now what a function is, on an example of a function, is the relationship between its inputs and its computed outputs. So to get the benefit from this code that is provable, that we're gonna use that in a way that we can have high level of confidence, we need to set some sort of boundaries and provide some sort of additional concept like that. So because this is what I was describing here, the function is a semantic relationship between its input and its computed output. So for that, this set of rules that we need to put in this function as a way to get the benefit of is to eliminate side effects in our function. What does it mean is that any stuff that alter the state of the scope out of this function is a side effect. So in other words, for example, network calling a database, timestamp, randomness, right? That anytime that you pass the same input, you get is a different output. Done operations, and you can boil down to anything that generate is a CPU hit, so any computation process, or a CPU time delay, right? Now, we identify some common examples here of how you can mitigate your side effects. And the idea of avoiding side effect, which is important here, is to, when you as the function caller want to use that, you want to make sure that that doesn't do funny stuff. It doesn't alter the state of the function here and there, right? So you have, for example, you are calling, let's say you're building an e-commerce app, pretty simple, straightforward. and somehow you want is to, by calling a method called sort by products, sort alphabetically by products, you want is to do that as it is. So you don't expect that change the state of the functions and here then apply some. So you don't want this kind of side effect or this funny effect. So how can we now is contain that, all right, or to prevent that, all right? One thing is that when you need to define your functions functions definitions, well, you can create that by actually is mapping that, right? So what happens is, for example, because we are all agree that this is a pure function, but what happens when you need to define stuff like this? All right, is this piece of code here that we're looking here is a pure function just because that and add another that is calling add to here and plus c is something that is outside of the scope, all right? And if these functions, even though that is actually returning something, is mapping its input with the outputs, but you have now this C. But what if we fix the C here? What if we say, hey, C is, it'll be always this value, right? It makes this code now pure. So why we are bringing here this is because if you have now a piece of code that you want to make sure, or a function that you want to make sure that it will work as expected, in the context of JavaScript, we want to reduce the surface area in which that function can be reassigned. So it means that by using techniques like this, so you define a function and another function that so you define a function that returns another function and so on and so forth. So the whole point of this is to reduce the surface reassignment area. And this is part of the core of this functionality, this functional approach. It's like, yeah, this is good, this is great. I want you now is to have certainty that anytime that I call this function, I won't reassign stuff here. Side effects, funny stuff won't happen. So this is if you have the ability to create your own functional pure functions, right? Which is great, right? However, sometimes we don't have that luxury, right? Because at the end of the day, function purity is increase the level of confidence. It's not a yes or no. It's just, well, we are quite confident. We have now high level of confidence that code base will work as expected. Because we are relying on all of this mathematical proof. And this level of confidence is on functions call, not functions definition. All right? So this is the example that we look is what happens when we can create our own functions definitions to define this set of instructions that will be pure. In other words, it won't cause side effects, and we can now represent the relationship between the inputs and the computed outputs, right? So this is great. Functions definitions. So for function that you have control of that. But most of the time, we don't have that. We have to rely on some sort of additional tools, all right, or libraries. And how can we now deal with those scenarios? So for example, when you need to read to a database, or you need to wait for something to be loaded, the DOM operations or the reading to a database, right? So what are the techniques that we can use there? Now, first is that There's two techniques that we can go with as a way to extract impurity. All right. One of them is the holding the lexical holding the lexical environment, as I mentioned here. All right, is containing impurity by containing the lexical scope, and then return a new copy of that, which is most of the time what you can do. All right. So in these functions, you define is now. So if you want to call a function, because it's this. So if you for some reasons you can have access to the function definition of that, and then you can now is wrap a functions holding the lexical scope, so that will be affected by the subsequent functions definitions. So this is a way of how you can work with this. When you describe this function definition, when you have that ability. However, when you don't, which is, I will argue that most of the time is what happened, all right, on functions calls. So the idea here is, this technique is called as brute force, and it's like take a snapshot of everything that it needs, call that function, and then return the state afterwards. So in other words, by the time that you call that function that causes side effects, you want is to take a snapshot of everything before you mutate the state, and then you restore the state afterwards. So the second techniques might not be quite feasible, because, for example, let's say you are reading to a database, you are somehow mutating the state of that. Here you have to explore some other alternatives. But the thing here is that at least you have now this particularly two techniques of how you can deal with. So if somehow you can extract the impurity of your functions, so at least you know that that section, that area, is now highly likely to cause this trouble, this issue here. So, but in any case, yes, good. Now, let's get into, all right, so let's get into is another tool and another topic that functional programmer, when they put these special sunglasses, all right, give us to anytime we want to work with functions, and that is they are obsessed with the shape of the functions, aka this type signature. So to make it more simple, in simple terms, to be able to describe that, is this function shapes, or this type of or this type signatures, is all about to know as the parameter and the arguments, know the difference. So parameters is the name of the inputs that you defined from the function's definition point of view, all right? And the arguments are the value that you pass when you call it. Now, they are quite obsessed with that, because this is pretty much like Lego blocks, all right? When you have some Lego piece with another, you want to try to make them fit to that. So this argument adapter, all right, or this shape of the function, which is just a fancy name to say, hey, this is the number of arguments and the shapes that we're passing a functions, and the number of arguments and shape that come up out of this. So this is the shape of the function. So we can is clarify that idea here with claw. All right. So the shape of a function in functional programming can be described like the shape of the function is the number and shape of arguments that we pass in, and the number and shape of the of things, and the number of arguments, exactly, we can call this, and the number and shape of the arguments that comes out of it. That's a good starting point for understanding function and shape in functional programming. Let me explain the concept here. In functional programming, the shape of a function refers to its type signature, what we're talking about, right? This type signature, essentially the contract, right? Is essentially the contract that specifies what inputs it accepts and what output it produces. This helps us to reason about function as mathematical mapping between different shapes. It's a mathematical mapping between different shapes. The shape tells us how many parameters the functions accept, what type of those parameters must be, and what type of the result of the function returns. Any constraint or relationship between the inputs and the outputs. The concept becomes particularly important when we start composing functions together, which is something that we're going to learn later on, or using high order function, or using this, which is a fancy way to say, hey, this is a function that receive is now a function or produce a function. And now that becomes quite important to understand, since this is now the foundation of what's coming next. This high order function and the shape of the functions, where here, and we look at this argument shape adapter, is to say, hey, functional programmers, their favorite type or shape of functions or type signature or the contract, okay, is unity. All right, just pass me one input and that's it, right? So arguments, shapes, adapters. And the another favorite functional programming or function is the binary, right? So you have now functions here. This is known as the high order function. When you take now a function and then you apply some sort of things with that function, and in this case we are now taking a function and returning its value for both cases, but also it can be is to take a value and return now a function, right? So functional programmers are quite obsessed with the shape of the function, pretty much like this Lego block. And the thing here is good because we look at these arguments adapters as a way to create now high order functions to make things fit. All right. So for example, if you have now a function that you have all of these arguments that you pass through, all right, so you just want to take now is the first argument of that, or the two arguments of that, right? Anything else you can just ignore. And this is a good another couple adapters like flip and reverse arguments adapters that perhaps sometimes you can see that, or you might need to go with. All right. So for example, flip is to say, hey, listen to now flip is the argument of the or the parameters of this function, all right? So the first parameter will be now the second, and the second will be now the first. It's going to flip the position here. Or the other is the reverse. It's like, hey, let me now is take all of these arguments and then now reverse them. So by the time that I consume inside of these functions, I know what is the order that I'm getting here. This is also something that, as you can see, for example, concept like apply or call from the functions is something that now, well, functional programmers actually have used this. So when you want to now is sorry. So when you want to now apply is a set of, or when you want to now is provide or call a function with all of these arguments, you provide all of this in a comma separated value. But when you want to get now all of this as an array, you apply them. Right? This is just a concept that comes from this functional program. So far so good, because this apply stuff here is something that we are actually used to that. But the thing here is that look at how we are using these high order functions to actually work with the arguments adapters to see if these two different Lego blocks actually fits here or not. All right, and then this is now another topic here talking about is the spread operator or the apply operator. So when you want to transform all of the input of these functions into an array, when you apply that, all right, or when you just want to get all of this value as a comma separated value. So this is interesting because, as you can see, these high order functions that we are now passing this function and we want to is do something with that functions, particularly is now changing the shape of the functions. So we are looking at now what are the things that we can do with these functions purity or with this function anatomy, and then make it fit, and then work with other, see how well it plays with other functions of this kind. All of this function in the kindergarten, how all of this play in different plays, right? How all of them interact with this. So this is now part of the foundation of the next particularly concept, which is point free. And I mentioned this because it's quite, this is point free means this. For those who are went through 8th grade or 9th grade, you were familiar with that. So there were some math class when you have now is the quadrant, when you're going to display something, all right? So for example, in the 3 dimensions, and when you fit, for example, in the z-axis, let's say when you fix, let's say you have now this quadrant, right? Pretty much like this. And when you fix now is on the y-axis, when you fix that on the y-axis at 2, and then you add now values on the x, you draw is a line. Why this is important? Why this point fix is something relevant here? Because this point, which is how now they describe is the arguments of these functions, functional programming, describe this data points like that. So this is another interesting concept here. Data points in functional programming are the arguments Yeah, that's a good way to think about it. In functional programming, data points or values are in the arguments that we pass in the function. But again, that's why we are looking at this. That is typically immutable. Once created, it doesn't change. Functions transform data by taking inputs and produce new outputs in complex data, blah, blah, blah. So the thing here is that I mentioned this concept of point free here because once you do that, once you fix that value on that axis, you can now in this case, draw a line. So this is pretty much what we are going to look, but from the functional approach. What our functions here are this is going to receive these data points, these arguments, right? And the data point is a concept from the functional programming, all right? And once you're able to fix now is the shape of the function, or in this case is the you have now a functions that you are sure that the shape of that it'll be the same. So the number of arguments it receives, it'll be the same. All right. Let me do this. So here we're gonna look now at if the data points, or if the arguments, or if the parameters of this function, the parameters, right? So if the parameters of these functions are the same as the, because it's that, exactly, if the data points or if the arguments of these functions are the same, all right, so by the time that you pass a function and then you return another function, if they have the same shape, we don't need to actually declare that arguments. So why is the value? Why are we buying here? You know, why are we purchasing here? This stuff here is known as because this is a fancy name to say that you can go and impress your developers by or your team by saying, "Oh, this is equational reasoning," and they say, "Wow, yeah, you learn new cool stuff." But this is just a fancy way to say is that if the function shape is equivalent to this and other shapes, they are now equational or equivalent, not in values but in shape. Okay, and that's part of the things that something that Kyle Simpson described is that this is when the readability decrease in the code base because now you have all of this yeah, this is when the readability starts to decrease when you are new to this. So, but remember that at the end of the day, we're looking here as at the shape of the function. It's at the parameters of the functions. All right, not at the arguments. It's the parameter of the functions. It's like how many arguments is going to receive. What is the shape and the type of this argument that is going to receive here. So the shape of that. So again, what are we buying here? What are we buying with this? So the TLDR is that if we can describe the relationship of our function much more straightforward, it will increase the readability from that, and especially if that functions now are whole on this mathematical ground. So because we can define now this function or this computation in terms of this mathematical conditions or statement here, when you say, hey, this is odd, is this, hey, let me now check if the value that I'm getting, their model, all right, if that is equal to 1, it means that, hey, well, that is this is an odd number, all right. If it's even, all right, it's the negation of this. So it's even, exactly is 4, right? So you might say, all right, this might be quite silly example here, but when you look at stuff, for example, as to look at the complement or the negation of that, all right, let's say you are in a list and want to explore is if one of those elements in that list actually is not present, all right, by using now this particularly high order function, all right, when you say, hey, give me now this function, all right, that is now going to take all of that, and I want to get, and then what I want is to get the negated value here. So the not function here is like, hey, I want to look at this number here and then say, hey, it's not here. So the idea of this is to, instead of defining is the relationship in terms of the computation here, we're gonna define is the relationship here much more clean without needing to pass is this values here. And that's why we're going to look at this, because sounds good in theory, but most of the time we learn by doing. So let's get into this. All right. Point 3 exercise.
Exercise to practice these point 3 refactoring techniques. In this exercise, you've been given several different functions. The README will indicate 3 of them. The output.
Let me now explore this. Nope. Really? Interesting. Log service, in.vp. Unit testing, main code graph, pull update, ecline, Pokemon spec, integration testing playground, no, plenty, really? May I close that? I think it is, I did. I think you got it. Good. Awesome. Awesome. This is in Python. Now let's go to create a new folder here. We're gonna see is point 3. Okay. And here we're going to check the finder, and then on the finder we're gonna say, hey, you got it. And this is the point 3 extra. Okay. Okay. And then you got it. Good. Point 3. Exercise. So let's take a read of this. Okie dokie. Yes, please update that. My shell. This is an exercise to practice point 3 style. Instruction: refactor the output printf and is long enough functions to use point 3 style. Hints: some browsers require console log to run against the console context. So f is equal to console log. F fails because of the loss of this binding. But this is how browsers work with that. Okay. Okay. Use binds to be safe. Why is that? Printf can be expressed in terms of a when that look like. GS function. Okay. And then you got this. When functions, and if predicate, return this. Is long enough is the negation of is short enough. Okay. 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 So use bind to be safe. Oh. Bind. This is a function JavaScript method for that. No, I'm calling you. I'm talking about bind. In the bind method of a function instance, create a new function that, when called, calls this function with the this keyword. So I want you to bind this function with this keyword. Okay, and the other is call and apply, and the other is bind here. Good. Yeah, I'm quite familiar. Yeah. Use bind to get to be safe. To pass now the context here. Okay, what is the exercise here that we want to do? Let's get into this.
Output function, the printf function, and the is long enough function. Those three functions you need to modify or refactor them to be defined in point 3. So if you look in the exercise file, you'll see.
Okay.
And the is long enough function. Those three functions you need to modify or refactor them to be defined in point 3. So if you look in the exercise file, you'll see they're all at the top. You have the output function, the printf function, and the is short enough function. The is long enough function. Those are the three functions that you want to refactor to be point 3 using the techniques that we talked about. There are listed in here a number of hints. These are important for you to actually complete the exercise. So make sure you check out the hints in the reading. It should help you with those three factors. Your test cases essentially are that the first one should print hello, then nothing should be printed by the next two, and the last one should print hello.
Okay, so I need to is refactor that functions, the output, bring if and is long enough to be a point free style. So but it means that bring if, okay, you can think of this in terms of when you look at this, okay, when a function is going to receive that, and here you're saying, hey, this print if function that is going to should print it, and the function message should print in it an output message, because here is going to now take is one call. So the first time you call this function is here. Exactly, the first time you call this function is going to receive this message, okay, and then you're going to hold that in memory in that function until now you call that function again, which is in this case, all right, and you're going to pass now that message. So it's sure enough, by the time it's passed here and it say, hey, of course it say, hey, we need to somehow is refactor this. Print if we need to somehow is refactor this, the print if. So because the idea here is just you want to pass is this function, all right, the first is the function and then the predicate, as they mentioned here, okay, as they put it here. The first function is when and the other is a predicate. This can be something like that, when and the predicate here. So this is when and the predicate followed by the arguments that you're going to receive from that function, and if the predicate is that, okay, so the goal of this is to say okay, and is to transform this is short enough, no, is to modify is long enough. Exactly, is to modify is long enough, output and print if, okay. So this function we're going to do now is, well, print that output. You're gonna pass that message. This example actually, this I think this will work. So you say, hey, node on point on 3 exercise GS. This will work. Exactly, this will work. But we need to put it now in a point free style. So my approach here will be is this. Print if and is short enough, because I want to transform that in is I want to modify it long enough. Print if and output. Okay. So the print if function it should accept is the function. Alright. I need to somehow is to receive is the parameters. Alright. So sure enough, I need to receive that. So the idea will be is to get this function here, all right, and so it's to get these functions, and then because all of this I want to transform into a point free, and to do that, let's take a look now at the solution here. Right.
All right, let's talk about the solution for this point-free exercise. As you read in the README, hopefully, you have three functions: output, printf, is long enough. Let's just go in that order. We'll start with the output function. Using our fancy technique of equational reasoning, we can see that the output function, which takes a single string, has, in this case, a compatible shape with the log function. So, ostensibly, it would seem that we could just say output equals console.log, and that should be our point-free definition. There's one little hiccup depending upon the JavaScript environment that you may be running in, which is that the log method expects to be called specifically against a bound object, and so if you're doing this indirect assignment, you may need to do a hard-bound version of it to the console log.
To pass is the context to that.
That's a point-free definition for output. Let's skip down to is long enough. Recall in our discussion we talked about the not function. Here's how that one looks. We said not takes in a function, it returns back a function that we'll call negated, which
receives the arguments, and then when those arguments are received, you're going to call that with the negate.
If we had that utility, then is long enough should be
now is this long enough is equal to not the function is sure enough.
There's our point-free definition for is long enough. Now the printf function is going to be slightly more complex to explain, but we need to go back to our hints. We talked about a utility which you would be able to expect from many of your functional programming libraries. This one is called when. It's referred to by different names, but it is essentially a functional if statement. It makes a decision to call a function only if something else is true. So the function that we want to call is the first input, and then the test that we want to perform to see if we should call it is the next input. And I've named that here predicate because that's a special term for a function that is going to return as a true-false value. So predicates are functions, generally unary functions, that return true-false. So we're going to have a predicate function that performs our test, and if it passes, then we're going to call the initial function with the arguments that it passes. It's kind of like a diff guard around the function. Only call it if this other predicate passes true. So I have manually queried this. That's a technique that we'll talk about later in the course, this idea of querying. I've manually queried it to receive these three inputs separately. And if you look at the bottom of the EX, you'll see that kind of happening the same with the printf function. The way the printf function was designed, it also receives inputs separately. As we continue towards our solution, we need to use some equational reasoning. So I'm going to switch to a separate file, and we're going to talk about this equational reasoning. So let's start with the printf function. Let's start with copy when function. We're going to put these alongside each other so that it's easier to see what's happening. So you recall at the bottom that we call printf, for example, we call printf with is short. How would we do it if we were going to use the when utility? What would that look like? Well, we would call when, and what do we need to pass to when? We need to pass.
We're going to pass is a function that we want to execute.
That we later pass that passes. What do we want to have happen in the case of succeed? We want to print it. So
We want to print it.
Output. And then what would we call? Well, the next thing is
Okay, when we just fulfill it,
what's our predicate? It's
is short enough.
And then what arguments need to be passed along to is short enough?
Is the message one.
So these two are going to give the equivalent output. Let's try to use our equational reasoning skills to figure out what is the point-free definition for printf. If I use some white space, hopefully it becomes obvious that when an output is returning a function that has the same shape, same kind of signature as the printf. So our printf point-free definition would be you could have done that equational reasoning in the call side. The way I did that, that's the way I like to do it. The other way to do the equational reasoning would have been to look at the function signature. To look at the fact that this function takes what is essentially a predicate and then some value passing to it. And that looks the same as this function and this function. Those two have the same generic shape. So then you would have been able to see, oh, if I just call away with an fn, I get back a function that has the same shape as me. That's another way of applying the equation. So take that back to our exercise file. And if down, here's our point function. Collecting those three at the top just to ensure that we see all of them.
Collecting all of these on the top. Holy moly.
Here's our solution for this exercise. There are certainly more advanced techniques.
Okay, that'll be all for this video. Take care. Bye-bye.